All right, this is chapter 7, sampling distributions. So I think this is probably one of the most difficult chapters in terms of concept. So I'm going to just walk through this. I think it's a good idea. Listen to this video and then listen to the other videos, read the chapter, do the problem, and then come back and listen to this video again. Review things. I think that's the best way to learn this, is you're exposed to ideas and then you work through problems, you hear other concepts, you hear words in context, and then you come back and you're like, okay, now I'm starting to understand it. I remember when I learned statistics, that's kind of the process I went through. I learned about sampling distributions as an undergrad, and literally I took exams on it, I studied whole chapters, and I still don't think I understood it. And it wasn't until I got into grad school and I started going back and being like, okay, now it's starting to make sense. So it is a difficult concept. Please reach out, ask questions, review material again and again, look at it from different perspectives, go online, try to get other information from reliable sources, okay, of course, to make sure that you're maybe getting it from different perspectives, because sometimes that helps with understanding things as well. So let's talk about sampling distribution. So it's a distribution, it's a probability distribution. So far, chapters 5 and 6, let's go back to those. Those were about probability distributions. What were they? Why were they important? But remember, probability distributions are important because they help us calculate probabilities, which is ultimately what we're interested in calculating, right? The probability of events. But for probability distributions, right, we need to understand our random variables. So for example, for a discrete random variable, we have, right, maybe the number of customers making a purchase. We go out and we find the number of people who, number of customers who made, right, with 0, 1, 2, and 3, number of customers making a purchase. We calculated their relative frequencies, which helped us create the probability distribution, right? So we can do that for the continuous. We did that for the continuous random variables as well. So that's the whole idea that we're building up to right now in this chapter, is that we have this random variable x. So remember, random variable x, it's just a numerical description of the outcome of an experiment, right? So here, working with discrete variables, I think that's a little bit easier. You have outcomes 0, 1, 2, or 3, and then we assign some numerical description to them, right? We calculated their frequencies. From that, we calculated the relative frequencies, which helped us understand the probabilities. We put all those together, and it created basically our probability distribution, which we could use to calculate the probability that, say, 2 people make a purchase, or at least 2 people make a purchase. So that's the idea behind the probability distribution. So we're actually going to use these concepts to understand sampling distributions. So the sampling distribution of x is the probability distribution of all the possible values of the sample mean x. So I know that's confusing. I'm going to go through an example to show you what this means, but it's important to recognize that a sampling distribution is a probability distribution. It gives us, right, the different outcomes and then their respective probabilities associated with that, and that's important because it helps us calculate the probability of an event. So let's think about an example. Let's think about, say, we want to know the number of minutes people exercise per day. We could go out and ask 100 people, hey, how many minutes per day do you exercise? They tell us. We calculate the average, and then we say, hey, this is a good estimate of the population. But say we collected the same information on a different sample of 100 people, we'd probably get a different mean, right? So the idea is that we could do this over and over and over again, where we ask 100 different people, how many minutes they exercise, we calculate an average, right? And every time we did that, right, we would, right, calculate values, their relative frequencies, which we could use to calculate and create probability distributions. So that is exactly what a sampling distribution is, exactly what I described. It's if you take a sample of a certain size and you collect data on it, and you collect some type of point estimate, for example, an average or a proportion, a mean or a proportion, and you did that over and over, and all the different values you got, if you plotted them, right, it would create your sampling distribution, which is basically your probability distribution for all the different possible outcomes, right? It's giving you the relative frequencies, right, which give you the probabilities for those different outcomes, which is important because then we can use that to calculate the probability of an event. Okay, so Kristen, why would we want to do that? Like, what event are you trying to calculate the probability for? Right? Well, remember, ultimately we're interested in some true population parameter, right? So we calculate a statistic from a sample, right, about our population parameter. Well, the question is that sample statistic that we calculated about the population, we might want to know, hey, what is the probability that that sample mean, for example, is within a certain distance of the population mean? Well, probability distributions, right, help us calculate probabilities. So what we can do is we can use our sampling distribution to calculate the probability that that sample statistic that we just calculated is with a certain distance of our population mean. So that's actually kind of informative, right? Ultimately, we don't really care about the sample, we care about the population. But we use the sample to calculate some type of estimate, right, of the population parameter. So it's kind of helpful if we say, hey, we calculated this sample mean. We don't know the true population mean, but we have like an 80% chance or probability that it's within so many units of the population mean. That's helpful for people, right? So if you're asking, hey, you know, how many minutes per day do people exercise? And you're like, well, we don't know the true population parameter, but, you know, based off of our sample, there's like a 90% chance that it's somewhere between 60 and 65 minutes per day. I made that up in terms of that statistic, but you can see how we go from, okay, we have some type of sample, and now we want to know about the population, and now we're giving people more information about how confident we are in that estimate. We're giving you some type of window, and we're giving you some type of confidence level or probability that the true population parameter is within that range. So that now is the idea of why we learned about probability distributions. Now we're understanding that, okay, we can use a sampling distribution, which is a type of probability distribution, to calculate the probability of something we're really interested in. So you might wonder, well, like Kristen, that idea of randomly sampling over and over and over again to calculate the sampling distribution, what's that all about? Well, that's just a technique that we use to basically create that sampling distribution, because it's telling us really a lot about the sampling distribution in terms of, okay, you have a certain sample size, maybe you know something about the population, maybe it's standard deviation. We take all that information and generate a sampling distribution which can help us calculate those probabilities. So the sampling distribution actually changes. It changes depending on the sample size that you use, and we're going to talk about that in another video. But hopefully right now, like I said, the whole idea is that the sampling distribution, right, that's what this chapter is about, it's a probability distribution. And what is it a probability distribution of? Well, it's all the possible values of the sample mean or the sample proportion or whatever we're interested in calculating. And we can use that probability distribution to basically tell us, right, the level of confidence or the probability that the sample mean that we calculated is within a certain distance of the population mean. So again, I hope this is making sense in terms of what a sampling distribution is. It's a probability distribution. Why is it important? It helps us calculate the probability of something we're interested in. What are we interested in? We want to know about a population parameter. We use a sample statistic to basically say, hey, there's a certain probability that the true population parameter is within this interval, basically. So that's the overview. Like I said, go through the chapter, look at the other videos, and then maybe come back to this video. And I think it will become clearer as you continue to study this chapter and even the textbook and statistics in general. But again, if things aren't clear, you don't understand, please let me know. Reach out to me. We'll definitely figure it out together.